in the chapter number 1 is you should understand what is rational numbers, children. It is rational numbers are in the form of P upon Q. Yes, last year you have already studied this. It is in the form of P upon Q, where Q should not be equal to 0. This is very important, children. So in rational numbers, denominator, there should be no 0. Okay, so this basic things you have to keep it in mind. And standard form is always never in denominator we write negative, right? This we can write it as in the minus P upon Q, right? So these are the few things which you have already studied, children. But this is very important, that denominator cannot be 0, right? We have also seen that a upon 0 is not defined, right? Any number divided by 0 is not defined. So let us move further. The main topic of our chapter is properties of rational numbers. So let us quickly revise all the properties. The first property is a closure property. Closure in the sense, if we add two rational numbers, then the sum is also a rational number, then we say that yes, addition is closed for rational numbers. Similarly for subtraction, similarly for division, similarly for multiplication. But for division, always when we divide the two rational numbers, the whatever answer we get is not a rational number always. So division is not closed for rational numbers, children. So we can say addition, subtraction and multiplication is always closed for rational numbers. Next is very important is commutativity property. Okay, we also say commutative property. What this property says is a plus b is equal to b plus a. That means where a and b are two rational numbers, we can interchange the rational numbers and then we can add. The sum will be same. That is a plus b. You can see here a plus b. If we interchange, if we do b plus a, still the sum will be same, right? These are the basic properties we have already studied. Next, a multiplied by b is equal to b multiplied by a. That means commutative property is true for addition. 1 minute. Commutative property is true for addition as well as for multiplication. But subtraction and division is not commutative for rational numbers, children. That means if a minus b, we cannot do b minus a. That is, we cannot interchange the places in subtraction and division. So this is what the commutative property tells. So next property is associative property. Now here three rational numbers. So that is a plus b plus c. In the previous there were only two. That is a plus b is equal to b plus a. So here now if there are three, we can group any of the two and then the third one is again added. That means in the previous one, if you see here, I have grouped b plus c. That means this bracket I'll solve first, and whatever sum will come in that I will add a, right? This a. But here first two numbers, that is first two rational numbers are added and the third one is then added to the sum of that. But still answer will be same, children. So this is the property. And similarly for multiplication also, if there are three rational numbers, whether you multiply the first two and then you multiply the third to that product, or either you multiply the last two and then the first one you again multiply the product whichever you got, the answer will be same. So hence we can say addition and multiplication are associative for rational numbers. Similarly, again subtraction and division is not associative. So for rational numbers, these two properties are very important, children, to understand. Based upon these properties, we are having problems in exercise 1.1 that we are going to see, right? The next property is distributive property. Distributive of multiplication over addition and subtraction. So this is very important, children. Now you can see here it is A, this you can see A multiplied by B plus C. Okay, so in the bracket it is addition of two rational numbers, and to this both A is multiplied. That means A is multiplied to both the rational numbers inside the bracket. So this can be done as well as in a form of AB. That is, I will do first multiplication and then I will add both the product, that is AB plus AC. Basically I am opening the bracket. First I will multiply AB and then I will multiply AC and then I will add them, right? Because addition is there inside the bracket. This is distributive of multiplication over addition. Similarly, over subtraction, distributive of multiplication over subtraction. In the bracket, if it is subtraction, first you multiply whatever outside the rational number is there to both the terms in the inside, and then you can do subtraction. So this is distributive of multiplication over addition and subtraction. Next one, which is very important, is additive identity and multiplicative identity. Now additive identity means such a number which we add to any rational number, the answer should be the same rational number. That is C plus 0 is equal to, now you can see here, C plus 0 is equal to 0 plus C is equal to what, children? Yes, C. So 0 is such a rational number. Now why I am calling 0 as a rational number? Because 0 can be written as 0 upon 1, which is again in the form of P upon Q. This is very important, children, okay? So now if I add 0 to any rational number, answer will be the same rational number, children. Hence 0 is known as additive identity of rational numbers. Similarly, multiplicative identity is which number, children? Yes, 1 is multiplicative identity for all the rational numbers, because if we multiply 1 to any rational number, answer will be the same rational number. So these are the important things to remember. That is, 0 is additive identity and 1 is multiplicative identity for rational numbers. Now additive inverse, children, this very important again. This is additive inverse is nothing but if there is a rational number A upon B, then its additive inverse will be minus A upon B. That is, if positive rational number is given, its additive inverse will be negative rational number, and negative rational number is given, its additive inverse will be positive rational number. For example, suppose I write 2 upon 3. So what will be the additive inverse of this rational number? That is minus 2 upon 3. Numbers will not change. Denominator and numerator and denominator will not change, children, in additive inverse. Only sign is going to change. Is this clear? So this is the additive inverse. Next one again, multiplicative inverse. It is also known as reciprocal. So reciprocal means you are going to interchange the numerator and denominator, right, along with the symbols. Okay, so if suppose here you can see A upon B, reciprocal or multiplicative inverse will be B upon A. For example, if it is 3 upon minus 2, so what will be the reciprocal? Yes, you are going to interchange the numerator and denominator. So negative 2 will go in numerator and 3 will come in the denominator. That is, negative 2 upon 3 is the reciprocal of 3 upon minus 2. So this is the multiplicative inverse. It is very important, children. And one more very important thing to note down is 0 has no reciprocal. Now why 0 has no reciprocal, children? Suppose I write 0. Okay, so 0 is nothing but in the rational number it is 0 upon 1, because always the rational number is in the form of P upon Q. So 0 can be written as 0 upon 1. If I take the reciprocal and if I interchange the numerator and denominator, it will be 1 upon 0, and we know denominator cannot be 0. It is not defined, children, right? So this you have to make clear that 0 has no reciprocal. I hope this is clear, children. And the next important thing is product of them is 1. Product of a rational number and its reciprocal. Now suppose I take a simple example, I'll show you here. It is 2 upon 3, okay, multiplied by its reciprocal. Now reciprocal is what? Again we are going to interchange the numerator and denominator. So reciprocal will be denominator is 3, which comes in numerator, whole divided by numerator is 2, which comes in denominator. Now if you multiply this, children, this 3 gets cancelled, 2 gets cancelled, and we get the product as 1. So whenever you multiply a rational number by its reciprocal, the product is always 1.